Welcome to this video. I'm Dr. K. Usha, Assistant Professor of Statistics, Sri Sharda College for Women, Salem 16. So in this video, I'm going to talk about Poisson distribution. So the Poisson distribution come under the category of distribution theory. So distribution, what do you mean by distribution in statistics? Distribution is statistics is a function that shows the possible values for a variable and how often they occur. So that is called the distribution theory. So it's further divided into two types. The distribution theory further divided into two types. One is a discrete distribution, another one is a continuous distribution. A discrete distribution is one in which the data can only take on certain values. For example, countable number of value. We can take for the 40. It's a countable. It's a single value. That is a discrete distribution because it take on a certain values. Next one is a continuous distribution. A continuous distribution is one in which data can take on any value within a specified range. Within a specified range means within the interval 20 to 40, 100 to 200, which sometimes it may be infinite. So this is the continuous distribution. So Poisson distribution come under the discrete distribution. Here we are using Poisson distribution for countable data. So first we will see the definition of Poisson distribution. A random variable x is said to follow a Poisson distribution if it is assumes only non-negative values and its probability mass function is given. So here x is a random variable. This x follow a Poisson distribution if it is assumes only non-negative values, which means positive values, then the probability mass function given p of x comma lambda is equal to e power minus lambda power x divided by x factorial. Here x takes the value 0, 1, 2, etc. and lambda value is greater than 0, which means there is no negative value, only positive values, 0 otherwise. So here x only vary from varying variable. Okay. Here lambda is known as parameter of the Poisson distribution and it is denoted by x follows lambda. So next we will see some points about the Poisson distribution. Poisson distribution has only one parameter which is called lambda. Why only one parameter? Some distribution having two parameters. For example, we can say that binomial distribution. There is a binomial distribution follows x follows binomial n comma p. There are two distribution n and p. But here the Poisson distribution has only one parameter. Then mean of Poisson distribution is lambda and also the variance of the Poisson distribution is lambda. Here, yes, see this the distribution of Poisson distribution, the which mean and variance are equal. So this is the only one distribution having mean and variance are equal. So here you can see that mean of the Poisson distribution is also lambda, variance also lambda, which means here both the values are same. That's why we are telling the distribution contains mean and variance are equal. Which distribution? Poisson distribution. So next see about the applications of Poisson distribution. So where we are using Poisson distribution and then which data we can taken as the application of Poisson distribution. So we can take rare distribution. It occur rarely. For that for the data we can taken as the rare event data we can taken as the Poisson distribution of application. So first we will see the number of deaths from a disease such as heart attack or cancer. It's happened rarely. So we can take an as the example of first one. The next one, number of suicides reported in a particular city. In a particular city, it's a rare. So we can take an as a village or city or state. That's also we can take an at the example of Poisson distribution. The next one, the number of defective materials in a packing manufactured by a good concern. And so it's a very important application of Poisson distribution in quality control. So everybody know about quality. Quality means fitness for use. That quality can be checked by the Poisson application. So if the manufactured when ready to shipment the product, they need to check the quality of the product. So they are using Poisson distribution that to check the product is defective or non-defective. Defective means there's some fault or error in that pin on the product. Non-defective means that the product is quality is good. So for the kind of situation, we can apply the Poisson distribution to take the whether the quality of the product is accepted or rejected. Based on the Poisson distribution, we can decide. So next one is the number of accidents in a some unit of time. So it's happened rarely. Then next one is the number of printing mistakes at each page of the book. So each page of the book. So we know about it. We have to use so each page is there any mistake in the each page, we can check with the help of Poisson distribution. We can see the example for later for this printing mistake at each page of the book. So next, before going to that, I will tell the one more example about a number of customers arrivals at a restaurant. So we can also take that also a application of Poisson distribution. Restaurant use the Poisson distribution to model the number of expected customers that will arrive at a restaurant per day. So the restaurant manager want to check the how many number of customers arrive per day. So he with the help of Poisson distribution, he study the customers arrival per day. So suppose a given restaurant receives an average of 100 customers per day. We can use the Poisson distribution to find the probability that the restaurant receives more than a certain number of customers. So with that help, they can improve the restaurant, then also know about the per day visit the restaurant with the customers. So next see about the another example. In a book of 520 pages, 390 typographical errors occur. Assuming Poisson law for the number of errors per page, find the probability that a random sample of 5 pages will contain no error. So in a book of 520, there is a book. That book contains 520 pages. There are 390 typographical errors. So that is what is mean by the typographical error. The design of the writing in the printed text or on a screen, that is called the typographical error. Assuming Poisson law for the number of errors per page, find the probability that a random sample of 5 pages will contain no error. So what they given? Assuming Poisson law for the number of errors per page. Per page, we are assuming Poisson distribution. Then find the probability that a random sample of 5 pages will contain no error. So the probability of random sample of 5 pages will contain no error. What is the probability of 5 pages will contain no errors? We are going to find out. So for the solution, the average number of typographical errors per page in the book is given by, here is the lambda is the parameter, we know about it. So lambda equal to, so what is the typographical error occurs? That means x, here x is a 390 divided by, in a total number of pages in the book is 520. So 390 divided by 520, we will get 0.75. So lambda is the 0.75. So we find the parameter of the lambda 0.75. Now substitute this 0.75 in the Poisson formula. We will get the random sample of 5 pages will contain no error. What is the probability of 5 pages will contain no error? Let's see. So using Poisson probability, we can find the errors. So from using Poisson probability of x, here error denoted by x per page in the book is given by p of x equal to x e power minus lambda power x divided by x factorial. So x takes the value 0, 1, 2, etc. That is the general formula. So now see that Here we already find out a lambda value is 0.75. Now substitute the values in the formula. E power minus 0.75 into 0.75 power x divided by x factorial. Here x takes the values 5. So what they given in the problem, what is the probability of 5 pages will contain no error. So here x value is the 5. So based on that, based on the given value, now we find that Poisson, you now find out the solution for this problem. The required probability that a random sample of 5 pages will contain no error is given by. So far we have know that the x is 5, then lambda value is 0.75. So what they given in that question, 5 pages contains there is no error. So there is no error, which means we are taking p of x equal to 0, because they mentioned in the problem there is no error. So p of x equal to 0, which is equal to e power 0.75 into 0.75 power 0 divided by 0 factorial. So 0 factorial means we know that 1. Then anything power 0 means 1. So remaining what we will get, e power minus 0.75 power the 5. Why we are putting power the 5? The random sample of 5 pages will contain no error. So that we are putting whole power 5. So from this what we get, that e power minus 3.75, which means 0.75 into 5, the answer is 3.75. So the required probability of random sample of 5 pages will contain no error is e power minus 3.75. So based on that application, I gave this one problem for your reference. So you can solve more problem. For that you can refer the book Gupta, S.C. Gupta and V.K. Kapoor, Fundamentals of Mathematical Statistics. In this book, you have many problems related to Poisson application. So, so I hope everyone have this book, those who are watching this video. So it's very helpful for, it's a very fundamental, easy to learn. Anyone, even non-statistician also study that book. This book is the user friendly. So so for further in this video description, they give we are given quiz. So students are asked to take the test quiz, and material also provided for your reference. Then reference also given. So the quiz, reference and the material, these all are given in the description box. You can click the description box, and they provide the link for that material, quiz and reference. So you can click the link, you will get the material, and you can take the quiz and take the reference material also. So thank you for watching this video.